All right, let's look at converting points between polar and rectangular form. I've got a bunch of blank space here because I want to use this space to work out the equations we'll use. They're simple, and rather than memorizing them, it's good just to derive them. So what I'm going to draw is just really the first quadrant. So if you've got a point up here, then I'm going to draw the equilateral triangle here. I'm sorry, not equilateral, the right triangle here. And this point, it has coordinates x, y, and it also has coordinates r, theta. Now, of course, the angle here is theta. This is y. This is x, and this is r, the distance from the origin to the point. And there are a handful of equations we can derive from here. If we look at sine and cosine, let's see, sine theta is equal to, now I could say that sine theta is equal to y over r, but instead of putting y over r here, I'm going to put the r over here. So y is r sine theta. And similarly with cosine, cosine theta would be x over r, but again, I'm going to put the r on this side. And the other two things we have are x squared plus y squared equals r squared by the Pythagorean theorem. And then if we look at the slope of the line here, the slope of this line is y over x. And how does that relate to theta? It's the tan of theta. So I guess we've got three equations there. Sine, one based off of sine, one for cosine, one for tangent, and then one from the Pythagorean theorem. So if we know these, we can convert between polar and rectangular. The only thing we have to be careful with is, tan theta. Well, actually, I guess what I should say is we have to make sure that we're in the correct quadrant. So let's look at, I've got several examples here I want to do, and I think each of these points is in a different quadrant. So first up, convert x equals 5, y equals 7 to polar, and give an answer in both degrees and radians. So 5, 7, that's going to be over 5 and up 7. And so I'm trying to figure out my theta and my r. All right, based off of those equations up there, what I'm going to use for my theta, to get theta and r, are going to be these two guys here. So r is going to be, well, r squared is 5 squared plus 7 squared. So that's 49 plus 25. That's 74. And let's see, can we reduce that at all? I don't think so. 74, if you divide that by 2, you get 37, which is prime. So r squared is 74, so r is square root of 74. And theta, now theta is not going to be a nice number because it's theta is going to be the arctan of y over x. And let's see, y is 7 and x is 5. And I said I wanted to do this in radians and degrees. Now, before we do this, I'm going to do it in degrees first, just by putting in arctan of 5/7 on my calculator. But before we do it, let's think about what the answer should be. This is 7 and this is 5. So that means that this is greater than 45 degrees because it goes higher than it goes over. So when I do arctan of 7 over 5, I get, sure enough, 54 point something degrees. So my theta is 54.46 degrees. And I want to convert that into radians as well. I could do that by multiplying by pi over 180. And I might as well do that. Equals that. which is equal to 0.951. Of course, I could also just do that using a calculator. Inverse tan of 7 over 5 gives me 0.9505, etc. I've got one calculator in radian mode and one in degree mode. You might say that looks weird having those two equal, but remember, degree there, that's kind of like a unit. So saying this is equal to that, it's not really any different than saying like 2 dozen equals 24. The degree is like a unit, so we could write that. So my answer is going to be root 74 and then 54.46 degrees, or root 74, comma 0.951. All right. Now that one was in the first quadrant, so we didn't have to do any. We didn't have to do anything special once we took the arctan to make sure that this was in the correct quadrant. That's might be a little different on these next couple of examples. X is negative 24, y is 7. All right. So if I put negative 24 and 7 on here, let's see, y is 7, x is negative 24. Now, remember, the angle we're looking for is this theta. So just looking at it, we can tell a couple of things. I mean, it's degree-wise, we can tell theta is going to be between, well, it's in the second quadrant, so it's going to be between 90 and 180. Furthermore, because that negative 24, because we go further back than we go up, we know that this angle here, the reference angle, is going to be less than 45 degrees. So I could go further and say, let's see, this 45-degree angle up here would be 135. So I guess I could go further and say that theta is between 135 and 180. And I'm just doing that because it's good to have an idea of what your answer should be. So let's do this. Well, first up, the finding r is easy. R is going to be the square root of 7 squared plus negative 24 squared. And I believe that's 25, but I'm going to verify it here. 7 squared plus 24 squared gives me 625, and the square root of that is 25. All right, so r is 25. Now tan theta is going to be 7 over 20, negative 7 over 24. Now, if I do the arctan, I'm going to do this first in degrees. If I do the arctan of 7 over 20, negative 7 over 24, it gives me negative 16.260 degrees. And that makes good sense because, you know, when you take the arctan of something, arctan always gives you something in quadrant 1 or quadrant 4. So this is minus 16.260 degrees. All we have to do is add 180 degrees onto it to get into the correct quadrant. So theta is 180 plus negative 16.260. So in other words, this 16 number I've got in my calculator, I'm just going to add 180 to it, and I get 163 point something. So theta is 163.260 7.4. I'm going to round this to 2 decimal places. 7.4 degrees. So my answer is 25, comma 163.74. Or if I put this in terms of radians, 25, comma, let's see, 163. To convert that to degrees, from degrees to radians, I divide by 180. I multiply by pi. Get 2.858 radians. Like that. And let's see, does this fit my stuff up here? Yeah, because we said that theta had to be between 135 and 180 just for the picture to be right. And sure enough, it's between those two. How many more examples do I have? I've got several more examples. So I'm going to stop this video here. I'm going to see why my cat is making noise. And I'll come back and I'll do these next 3 examples in the next video.